This video is about graphing equations of lines. One method for graphing a linear equation is to use a table of values. This is probably the slowest method, but we always learn it first when we're learning how to graph a function. In order to use a table of values, we want y to be by itself in the function. We're going to start by dividing both sides of this equation by 2. So y equals negative 2x plus 3. Once y is by itself like that, we can easily use an input-output table to graph this function. So for our inputs, because I know it's going to be a line that's a linear function, I don't need that many points. I'm going to use 3 points. I usually use negative 1, 0, and 1 as my 3 input values. And then I'm going to plug those in for x and determine what my output values are. So when I plug in negative 1, my output is 5. When I plug in 0, the output is 3. When I plug in 1, the output is 1. I'm going to put those 3 points on the graph. Negative 1, positive 5 is here. 0, 3 is here. And 1, 1 is here. And connect them into a line. This line goes on forever in both directions, so we put arrows on the ends. A second method for graphing is to use the y-intercept and the slope. This is especially convenient if the line is given to you in slope-intercept form. So the slope here is negative 1/3. The b is 4. I'm getting those letters from y equals mx plus b, right? M is the slope and b is the y-coordinate of the y-intercept. So since I know that the y-intercept of this line is located at 0, 4, from just looking at the equation, I'm going to put a point at 0, 4. And then I'm going to use my slope. If the vertical change is down 1 and the horizontal change is 3, I can figure out where my next point will be by going down 1 and over 3 units to the right. I can continue doing the slope in either direction. I can see what the trend is going to be here. So if I want to get a third point, I ran out of room on the right, but I can go to the left instead to see that my next point on the left would be here. And then I'm going to connect my 3 points and put arrows at the end. This is still part of that second method here. This is probably the fastest way to graph lines, but you must make sure that the equation is in slope-intercept form before you use this method. So in this example, it's given to you in standard form. You want to get it into slope-intercept form, which means get y by itself on the left side of the equation. So we're going to start by subtracting the 2x. We'll be left with 3y equals, bring down the negative 2x, then the positive 9, so that it's in slope-intercept form. Divide the entire equation by this 3. Y equals, since this cannot be simplified, I'm going to leave that as negative 2/3 x. And that's okay because I like when my slope is a fraction. 9 divided by 3 is a whole number, so plus 3. Now the equation's in slope-intercept form. I can see that the m is negative 2/3 and the b is located at 3. That means the point 0, 3 is on the line. That's my y-intercept. And from there, to find my next point, I'm going to use a vertical change of negative 2, so down 2, and a horizontal change of 3. So I'm going to go down 2 over 3 units. I ran out of room in that direction. If I tried to do that slope again, I'd go off the graph. So I'm going to do the same thing in the other direction, determine that my next point is up there, and then connect my 3 points. Put arrows at the end to show that the line goes on forever. A third method for graphing a line is to use the x and y intercepts to graph. Now this only yields 2 points, but you can connect 2 points in order to get a line. The 2 points that you're going to find are the x-intercept and the y-intercept. This is a good method to use if the equation is given to you in standard form. If you don't feel like getting y by itself and converting it to slope-intercept form, this is a good method. To get the x-intercept, it's just the point where the line is going to cross the x-axis, at which point the y value is 0. So we're going to replace y with 0 in the equation. I don't usually show the work for that because if I multiply anything by 0, that term is just going to go away. So really what I'm left with is 2x equals 10 and x equals 5. So I know that I have an x-intercept located at 5, 0. And then my y-intercept, I'm going to do the opposite. I'm going to change x to 0. Again, I don't normally show that first step because when I multiply something by 0, that term is just going to go away. So I'm left with negative 5y equals 10 and y equals negative 2. So I know I have a y-intercept, 0, -2. Put those 2 points on the graph, 0, -2, and 5, 0, connect them, and there's the line. Horizontal lines are a special case. A horizontal line, which as you know just goes straight across from left to right, has no slope, is a slope of 0. Their equations look like y equals some constant number. So an example would be y equals -3. It's just the set of all the points that have the y value of -3. So the y value here is -3, but the y value here is also -3, the y value there is -3, and so on and so forth. So when you connect the set of all points that have a y value of -3, you get a horizontal line. Vertical lines are just the opposite. Now we're looking at equations of the type x equals some constant. So we're looking at the set of all points that have an x value of +2. So the x value is 2 right here, but it's also 2 here, and so on and so forth. So when you connect the set of all points that have an x value of 2, you get a vertical line. And that is all.